We shall start with thermal stresses or temperature stresses. Previously we are discussing with bars subjected to external loads. Now we are going to consider bars subjected to change of temperature. How the stresses are developed due to change in temperature. There is no external load, only temperature change is occurring, either fall in temperature or rise in temperature. So the best example is you just consider a bar of length L and cross-sectional area capital A, and it is subjected to an increase in temperature of T degree centigrade. So when this particular bar, it is fixed at one end and it is of length L, and if it is free to expand, it is going to expand by a certain length. You call it as, say, this distance is, say, delta. So delta is the expansion occurred due to a rise of temperature T degree centigrade. So if you have got for the material, alpha is the coefficient of thermal expansion per degree centigrade. Coefficient of thermal expansion is alpha. You will have the extension delta is equal to alpha into T into L, which I have already studied in +2 classes. Change in length due to temperature change is equal to coefficient of thermal expansion into the temperature change into length of the bar. So you have got the change in length. Now from this you can find out what is the strain. Strain is nothing but change in length to original length. So we will have here alpha TL divided by L equal to alpha T. So this is the strain. So if you know the strain, you can find out stress developed, which is equal to strain into Young's modulus, because Young's modulus is equal to stress by strain. You will have stress is equal to strain into Young's modulus. So we will have here alpha T into capital A. Now this is the stress developed, but all this stress will be developed only if you just restrict this from expanding. So if I am saying that this particular bar is not allowed to expand, that is, this expansion is to be prevented. So what will happen is, to prevent this expansion, you have to apply a compressive force over here equal to, say, capital P. So if this expansion has to be prevented, a compressive force P has to be applied to prevent this expansion. So you will have the force P is equal to sigma into A, or this is equal to alpha T E into A. So this is a compressive force developed when it is a rise in temperature. So if it is a fall in temperature, what happens? This will compress, so it has to be pulled to come to this position. So this will be a compressive force when if it is a rise in temperature, and it will be a tensile force if it is a fall in temperature. So this is the concept of temperature stress. I will repeat once again. So we have got a bar of length L and cross-sectional area capital A, and this is subjected to a temperature change of T degree centigrade. So if this particular bar is free to expand, it will expand by a length of delta. So if the coefficient of thermal expansion of this material is alpha per degree centigrade, you have got delta is equal to alpha into T into L. This is the expansion. So you, from knowing the expansion, you can find out the strain. Strain is equal to change in length to original length, that is alpha TL by L, which is equal to alpha T. So knowing the strain, you can find out the stress developed. Sigma is equal to strain into Young's modulus, that is alpha T into capital A. So I have told you already, if this is free to expand only, you are getting this elongation. And if you are restricting this bar at this particular end, so that it is not free to expand, a compressive force will be developed in this particular supports, so that this particular expansion is being prevented. So a compressive force is developed, so that compressive force P is equal to stress into area. Stress you have already got, so that is alpha T into E into capital A. So this is, if it is a rise in temperature, it has to be pushed to its position, that is compressive force will be developed if it is a rise in temperature, and if it is a fall in temperature, it will be compressed. So in order to keep it to this position, it has to be pulled. So it will be a tensile force developed if it is a fall in temperature. So there is a concept of temperature stress. This is simply due to temperature change.